Hi everyone. I'm going to bring us back to technology, and in particular to this type of technology. And I'm going to do that by giving you a very, very brief overview of natural language processing and sort of where we are in this field and a couple of applications, just examples of applications and what we can do with it. Okay, that's working. So what do I mean by natural language processing? Put in very simple terms, it's basically processing of natural language by computers to do a given task. And that is a very interdisciplinary area of research and application, so it involves many other areas: computer science, linguistics, cognitive science, artificial intelligence, of course. And a big chunk of that artificial intelligence and computer science is actually machine learning, and as you see later on, mostly nowadays deep learning, but various versions of machine learning as well. So the ultimate goal of natural language processing is to create systems that would be able to understand language, act on it, perform a task, and then also produce language for certain applications. And we tend to separate these two subgroups of natural language processing into language understanding and language generation. So for some applications, you're more interested in taking some text and understanding it and maybe running a command or doing something with it, but not generating an answer. For other applications, you'd be potentially taking a text or taking some structured information, some tabular data, and then generating a language from it. And some applications would do both. You'd start with text and you generate text. And we see some examples of that. And throughout the talk, what I mean by language here is written language. Of course, there's also a lot of work in speech where we consider it a separate area of research where you're doing speech recognition, speech generation. And even though we may use speech as input, here I'm going to assume that there is a step that will do the recognition, and then natural language processing is actually doing something upon the text that is written. So the ultimate goal, like I said, is, and some of you may recognize that, this is from Space Odyssey, and what we want is basically a model that would be able to communicate with humans. And this particular case is a model that is very, very clever. It doesn't only process language, but it has a lot of reasoning and has empathy and has its own intentions, which might not be the same as those of the human. So this is sort of the really ultimate utopian view, if you want, of natural language processing. Closer to reality, you could think of devices like Alexa or the Google Assistant, where, again, you're communicating through speech, but there is a process that recognizes speech and then does something with the text and produces an answer if needs be. How far have we gone, and are we there yet? These are just some examples from real Siri communications. I'll allow you to read them. I really like the last one. So actually, the last one shows that the model is not really doing a terrible job at understanding the language. It's getting the speech right. It's sort of trying to guess what the sentence was about, and it's suggesting something that might be relevant in some contexts, but not in this one. Definitely not a lot of reasoning there. And so, yeah, we're not there yet, but there has been a lot of progress recently. And if you use any of these assistants, you see that this is the case for many languages. Right, why are we still not there? Well, we're talking about language, and language different from sort of tabular data where you have numbers that each number maps into something. Language is actually much more complex than that. One of the main challenges is ambiguities. So when you say something, sometimes you mean something and sometimes you mean something else. And this ambiguity could be at different levels of language. For example, the level of words. So if I have, can you bring me the file? Do I mean like the folder kind of file or the other type of file? More interesting, I have structure ambiguities. I saw the boy with a telescope. Who has a telescope, the boy or the person who saw the boy? Semantic ambiguity. So here we have the word rabbit, which most of us would think of it as the animal rabbit, but there's a slight variant of that meaning. It's still the animal, but it could be that or that. And then finally, bit of more, even higher level of semantic ambiguity is to do with intentions. Like, what do we actually mean by a text that we say? That's an actual picture from Edinburgh Airport, and it's unlikely that in this case they're telling you to sit on that big ashtray. Call me a cab, unlikely that that's what you want. So these are all different levels of ambiguity that we have in language, and for any application that we build, we need to deal with this ambiguity somehow. There are a number of applications where there has been different levels of success. Probably the most familiar to many of you would be conversational agents, such as you have in Google Assistant or Siri or Alexa. But there are other applications that are quite popular in businesses as well, such as sentiment analysis, and we'll see some of those. Translation, applications that detect certain types of language use, like abuse or offense or fake news, which I guess you have heard of earlier. And we'll see some of this one by one. But I wanted to first bring you to sort of a very, very brief description of what would be the sort of main back end, what's behind these models nowadays. There's been so much work done in the last 50 years or so. But nowadays, everything is pretty much guided by deep learning. And these are models that learn from a lot of examples of data. And there's generally two levels of learning in the process. One level is what we call this sort of pre-training or general representations of language. And then we have another level, which is building a model on top of this general representations, a model that is specific for a given task. And when I say general representations, I normally mean a representation of words. So say I have the word file, which we've seen before, and I want to somehow represent this word. So the way I normally do it is these models would do it is by going to a very large collection of data, of texts that are, I don't know, complete documents or sentences where I have different contexts in which the word file can happen. And I would basically look at different words that happen with it and try and come up with a representation that would be specific for certain contexts. So I would have a representation of file in the context of it being the folder file, and a representation of file in the context of it being something that you file your nails or something with. And this is done for each language or even across multiple languages. You can have multilingual representations of words. But just think of it as a way of pre-extracting information from as much data as you need. And the interesting thing is that you do this is in what we call unsupervised ways. So there is no annotation there. The only thing I have is text. So say I take the entire web in English, and I just learn this mapping between words into some space where this space represents possible contexts in which these words happen. And one model that's very popular nowadays, and you might see it again and again, is so-called BERT model, and this just means it's basically one implementation of these ways of extracting information from text. And once I have this, and I'll have, say, it's a vector per each word in each context, I can use this for different applications. So I could do what we call fine-tuning, which is basically specialize in this for a given application. And for that, normally I require some label data, say it's sentiment analysis, then I'll need a lot of texts and annotations for whether it's positive or negative, and then I'm going to be querying these pre-trained representations to train a model to detect sentiment in text. And this is just a bit of terminology because you might come across these terms. I mentioned this BERT, but there's also even more recent things. This is all from the last 2 years or so. And all of this try to do the same thing in better or worse ways. And they like to use Sesame Seed characters for that. But yeah, the idea, like I said, is to go to this large collection of text and look at occurrences of certain words and the context in which they happen, and then generate a representation for these words in context. So we call this contextualized word embeddings. And embeddings just mean I'm taking words in its discrete form, say file, and then I'm generating a vector of many numbers which represent the context in which that word can happen, or multiple vectors in this case. Right, I'm not going to get too technical, but I just wanted to give you a little bit more information about this one model that seems to solve all of our natural language problems nowadays, this model called BERT. And it's based on a very powerful architecture that Google proposed recently called the transformer architecture. This is a deep learning architecture that is fairly complex, but there's open source code out there, and basically anyone with a little bit of background in deep learning can take that and train a model and build an application on top of that. So the way it works is, I'm actually going to show you an example which makes it easier. So this extraction of the representations for words will go through sentences like this, or any snippet of text that you may have, normally not a full document, but a shorter version of it. For example, the weather is nice in Montevideo in November. And then there's this black box, which is the transformer model from Google. And it will hide some of the words in the, hide some of the words in the sentence and try and predict them as output. So this is what we call a masked language model, where I'm masking, for example, the word nice here, and then I'm going to train this encoder, this transformer, to predict this word. And I'm going to do it repeatedly with many words, about 15% of the words in each sentence, and I'll see multiple sentences, I'll see millions of sentences, and by doing that, what I'm learning is those H's at the top there, which basically means, the pointer it's not working, the H's are some hidden representation, which basically means some vector for each of these words that I'm predicting from seeing a lot of examples where I hide the word and I look at the context as a way of predicting the word. So the question becomes, can I predict nice from the weather is in Montevideo, and then other examples of, I don't know, the room is or looks, and then something else where nice could be a possible word that comes after. So this is a very, very powerful model. The encoder here is this fairly complex black box for which there is a lot of code out there, but in practice it works really, really well. And more interesting, once you have this H's at the top there, which are these vectors for different words, you can plug that into any application. Say the application is a classification of sentiment, where for each word in the sentence that you want to classify, you're basically going to query this. You can think of it as a database of like words and context into a vectorial representation of those words, and you're going to get this vectorial representation, which you can then use for an application. In this case, you could use like the representations for all of the words in the sentence. Walking is good in Montevideo in November, as a way of predicting a sentiment. Is it positive or negative? So this has been used for a very large number of applications and has been proved successful. These are just some examples of applications. Classification, like I said, the sentiment analysis, I have a text and I train it based on this pre-trained word representations to predict sentiment. Entailment, which basically means does one sentence include the meaning of the other sentence or entails the meaning of the other sentence. And for that, I have two sentences as input. I could use that for any number of, applications that have any number of inputs. For example, question answering, I could encode the question. I could encode the answers at training time. And at test time, I'm encoding the question. I'm predicting the answer, all using these pre-trained representations. And the details don't matter there. But this is just to give you an idea of how well this performs, where GLUE here is basically a benchmark, which includes about 10 different natural language inference tasks. And the tasks are, for example, given two sentences, I want to measure how similar they are in meaning. Or given a question and an answer, I want to measure, is this a possible answer for that question? For example, if you have a chatbot where you're retrieving pre-created answers, this could be a valid task there. And the higher the better, 100 would be the upper bound. But in the space of 2 years, the state of the art went from 72 to 88 accuracy, which is fairly large there. Right, so how can we do this pre-trained representations? Or of course, there are other ways of modeling these tasks, but this would be sort of the state of the art for most of these tasks. From very basic applications, which you're probably all familiar with, such as filtering content, in this case, spam, So one could have a layer that does that automatically, and many of you have that in your email that is based on the language that comes in the email as well as the sender, but in a lot of cases the text as well. Sentiment analysis, and I'm giving in some cases some links to either open source code or demo of that, which you can check later. And yeah, in this case, you would need some training data, which might be either just positive or negative, or you actually have a range of possible sentiments from positive to negative. And this, of course, can be used in a number of settings. Language prediction, which is probably something you're all familiar with if you use messaging or anything on your phone that might have that. So you start typing something, it will suggest the next character or the next word. This can be a direct application of this BERT language models that I mentioned. Email also has that. Another very interesting application, and the level of complexity here is going up. Machine translation, if you're familiar with Google Translate, you might have used it a few years ago. And then if you tried it again recently, maybe 8-9 months ago, it changed into this deep learning models, and the quality went up by a lot. And not only Google, you have companies like Facebook, which also have their machine translation models, claiming that we've reached human parity, meaning that these models are as good as humans. Of course, this was tested on a specific data set. In the general case, if you try and translate something like poetry or tweets, you're unlikely to get the same quality as a human would. But this is translation of news, and it did very well. And then finally, chatbots, which is something that's very popular now, and there is a lot of work using language. In many cases, a chatbot is sort of a retrieval tool where you already have some possible answers that you want to give to the user, the customer, or you may have possible parts of the websites that you may want to map the question to. But in other cases, you're actually generating an answer using natural language processing techniques from putting together information from different parts of content. And this is an example of a tool where you can actually use it to generate as well. This is a sort of a general tool that you can customize for that. And as you, yeah, in this case, the answers are pretty simple, but you can actually get quite complex natural language answers there. Right, just wrapping up. So I believe that NLP can support businesses in many ways, and there are many examples of companies using it, and we can chat about it over lunch. And especially in the last 2 years, NLP has evolved a lot because of mostly deep learning. And for a number of applications, it has been proven effective, reaching very quality levels that are very close to human performance. Especially if you have a lot of data, or at least significant amount of data, to do this second step, which is the so-called fine-tuning. So the general representations that I mentioned before, these BERT representations, they can actually be reused, and there are models out there that you can take and already use. You can query them. You don't need to build them from scratch. Of course, they're built for what we call the sort of general domain text, as much text as one can find. But if your application is, say, I don't know, sentiment analysis in the e-commerce domain, you'd have to do this step of fine-tuning such that it works for that specific domain. And for that, you'd also need some data. And there's a link for state-of-the-art performance for various tasks, most of them using this idea of pre-trained representations followed by fine-tuning. And I'm happy to take questions as well. Thank you.
Time for 2 questions.
Okay.
So let's start with the first one. If a machine could talk like a human, would this mean it thinks like a human?
It's very philosophical.
Yeah, it's very philosophical. We can go over to.
Oh no, it's an interesting one, and the answer is probably no. Machines can resemble humans when producing language, but it doesn't mean they're reasoning like humans. There is a famous test called the Turing test, where people are testing exactly that. If you having a conversation, and on the one hand you had a machine on the background, but you don't know, and in the other iteration you have a human, you're supposed to tell if it's a machine or a human. And there have been models that have won the Turing test by fooling a human without doing much reasoning, by just using pre-created text that looks like human text or that is actually human text, but finding a way of fetching those answers when they fit the context, basically. So no.
So let's do this as the last one. What, in your opinion, is the most exciting potential commercial application of your work?
There are many, but I would say in terms of volume of, my main expertise is machine translation, and for that there is like a huge need, and a lot of content that we produce doesn't get translated just because there isn't enough manpower to do it. But I think probably the hottest application nowadays, which people are realizing that can be automated, is chatbots or dialogue systems or conversational agents.
Thank you so much for a fascinating.